In this video, I want to talk about the use of chain rule to find tangent lines. And you'll recall every tangent line needs two things. It needs a point and it needs a slope. Okay, so I'm going to start with the point, and of course I know that x is 2. I had to give you that, but we plugged 2 in here. So 2 squared is 4. 4 plus 6 is 10. Minus 1 is 9. And the square root of 9 is 3. So now I know the point is 2, 3. Now to get the slope, well, I need the derivative. Okay, so I know I'm a little bit pressed for room here, but let me put kind of a rewrite of this function up here. X squared plus 3x minus 1 to the 1/2. I like to write it with an exponent. And I'm going to use chain rule. So this is going to be my inside function. So my derivative, dy dx, is going to be, I'll put the 1/2 up front. I leave the inside exactly as it was. Now it's to the negative 1/2, and then remember I multiply by the derivative of the inside, so 2x plus 3. So doing a little bit of rearranging, and again I'm kind of assuming you have a handle on chain rule, and if you don't, go back and watch some videos on that. But the 2x plus 3 is on top, and on the bottom I've got 2 and the square root of x squared plus 3x minus 1. So to get the slope, I'm going to plug 2 in to this. Okay, so 2 times 2 plus 3, I've got 7. I'm just going to make a little note to myself that there's a 7 on the top. On the bottom, I plug 2 in. I get 4 plus 6 minus 1. I get that square root of 9 against the 3. 2 times 3 is 6. I'll make a little note to myself there. So the slope is 7/6. So my tangent line is y equals the slope, x minus the x coordinate, plus the y coordinate, and that's my tangent line. So the tangent line idea doesn't change at all. We still need a point, we still need a slope, but we can use some of our new rules to get the slope. Okay, so let's do another example. In this one, we need the point, we need the slope. The point, well, it says x is 1. So if I plug 1 in, I get 6 minus 4, that's 2. 2 cubed is 8. Okay. The slope, well, I need the derivative. So this is going to be my inside. Okay, so dy dx. Bring the 3 out front. It's going to now be to the power of 2, but I'm going to leave the inside exactly as it appeared. So 6x squared minus 4x. And then I'm going to multiply by the derivative of the inside. So 12x minus 4. Now I have the derivative. I'm going to plug 1 in. So this 6 minus 4, this is 2. So 2 squared is 4. So 3 times 4 is 12. And this is 8, right? 12 minus 4 because I plug in 1. So I end up with 12 times 8, which is 96. So my tangent line has an equation of 96 times x minus the x coordinate plus the y coordinate, just like that. All right, last one. I need a point, I need a slope. Well, the point, I gave it that x was 4. I plugged 4 in. 4 minus 2 is 2. 2 squared is 4. So 6/4, or I could reduce that to 3/2. And to get the derivative, I'm going to start by rewriting this as 6 times x minus 2 to the negative second. So my derivative is going to be negative 12 x minus 2 to the negative third times the derivative of the inside, which is just 1. So I have negative 12 over x minus 2 cubed. Okay. So now I plug in 2, and I get, 4. I get 4 minus 2, that's 2. 2 cubed is 8, so I have negative 12 over 8 which reduces to -3/2 is my slope. So my tangent line is that. So don't lose sight of the fact that tangent lines are the same as they always have been. You just might need a new derivative rule to find the slope.